So good morning, everyone, and thank you, Richard, for that welcome. Yes, my name is Steve Rowland. I work for Airbus, and it's a pleasure to be here. I had a first great day yesterday, as Richard said, and so now I'm going to change things up a little bit and talk some more about the defence ground segment. So we're going to talk about what really makes ground segment in defence different, to start with. So where are we at today with military space? Not just MilSatCom, but some ISR piece as well. And then what are some of the challenges and where are we going with that? And then what are some of the challenges that we're facing to get there? So I think my role is pretty relevant to this discussion. I've been with Airbus for 20 years and I work in secure connectivity in the defence and space part of the business. Which really means that we deliver capability for the warfighter. It's not just about the equipment, it's about people, it's about processes, it's about tools, all those things that come together to actually make the whole system of systems. And before we dive into the ground segment piece, a bit more introduction just on my background, I guess. So, anybody in the room that's a SATCOM-aholic, just like me and Pete Lim? Might be a few out there. So, antenna on your left-hand side. And we take a guess as to what that one is? Quite well known. Come on, Marius, you should be. It is an X-band terminal. Excellent. So, good start. It is indeed. That is a 670 at Rowland. And there it is. What is that now? You know, nearly sort of 26 years ago or something like that. I'm actually in that photograph. So I have a military background, and I've been in MilSatCom nearly 30 years. And I was talking to Pete yesterday, and he said, Steve, you must have started when you were 12 or something like that, which I thought was very kind of him. But I think, as you can see, the picture on the left is now, the picture on the right was then. I think the 670's probably fared better than I have, or most of us in that photograph. It's still going strong, thankfully. Okay. So, I've been involved since Skynet 4, through Skynet 5 and the PFI that Pete mentioned yesterday. I also did a short stint in 3.5 years in the UAE, delivering a MilSatCom capability there, really from, well, I like to say, from sand to SATCOM, which took about 10 years, training the people, delivering the systems and so on. Really interesting. And that means, yeah, I do enjoy travel. And in my former years, I had some nice all-inclusive holidays to such places like Kabul, Qasar, Basra, and places like that. So I guess what I'm saying is I've got a mix of the user, the system integrator, the service provider, so I can bring those kind of perspectives, I think, to the MilSatCom and MilSpace world and this presentation indeed. So moving forward. What does the ground segment look like today? So that was the first topic that I mentioned. So in Airbus, we're seeing defence globally still, despite the NGSOs and the advent of new space, we're still seeing defence wanting to have their sovereign capability that they've got control of. And I think Pete alluded to that yesterday. But certainly in around the world, in many other countries, I won't mention them, obviously, but I've talked to a lot of customers over the last couple of years, and they still want that sovereignty on-premise, on-site, and control over their assets. So they want that high level of assurance, they want that high level of security. So, now I've used this slide. Sorry, it's for you at the back, you probably can't see all the words, but that's not that important. The important thing is that the MilSpace environment is looking something like that these days. There needs to be, well, let's start with the three elements to start with, if I can make this laser work. Is it fucking... It isn't. There's that. It was working earlier. Okay. So I will point instead. I'm mic'd up, I can do that. So in the green, you can see that there's a MilSatCom environment. So that includes the ground segment on the host country. On the left-hand side there, that might be UHS, X-band, KA, all the different bands, etc. And then you've got the remote terminals on the other side, also in green there. You'll see protected modems, crypto, routing, and terminal management, because the end users don't want to have to think about, I've got to set up my Cisco router, I've got to program my crypto, or whatever. They just want to turn it on and be able to think about the bullets that are coming over their head and getting out of the way, essentially. So automation, using all of the good network management systems that we've got today to manage that end-to-end piece. In the blue here, and whether it's an ISR satellite or a MilSatCom satellite, needs satellite control. So that's the second different ground segment type that we have in defense. Again, really secure is what they want. Always working is what they want. So we have crypto units that talk to the satellite specifically, and quite niche capabilities there for secure tracking, telemetry, and control. And then the ISR piece, where that's the pink. So there's a downlink there, downloading that data and information that the sender is getting, whatever it might be, on that satellite, and downlinking it to the ground station. So those are the three types that we're looking at in defense. But the important thing, I guess, there, in terms of the picture, is that there's an end-to-end systems approach, and everything's glued together and it works. And again, as Pete mentioned yesterday, that's a challenge. Okay. So, what else is there that makes defense ground segment rather than commercial? Well, it's basically what you see here in front of you. And this is the threat environment that we face. And again, in a contested environment that Pete mentioned yesterday. So RF jamming, etc. GPS jamming, really easy to do, as Pete said. TT&C. So as you can see, you can relate back to the picture I just showed you about some of those countermeasures, having crypto, having really high cyber security around the whole thing. So that's what we need for our ground segments. What does that all mean? Really, at the end of the day, an adversary, when they want to start dropping bombs, the first thing they're going to do is want to take out your command and control. And that means taking out your communications or disrupting your information coming from your sensors. So before that attack, they're going to jam your satellites, they're going to cyber attack the ground station, create that chaos and confusion, and then they're going to make the attack so that you can't repel. That is why ground segment in defense is as it is. Again, a little bit more detail there, but there are a number of threats. In fact, we count 30,000 of them at any system in MilSatCom. Obviously, I'm not going to list those because they're a bit more classified, but they're not just about hacking in, because obviously closed system, again, that's very difficult to do. But you have to have people managing and operating the equipment, so that's another threat vector that we need to look out for. So there's vetting, there is making sure that you have more than one person in the room at any one time, that sort of thing. So there's really a lot to think about. But how does that impact on the design of our ground segment? So all of that, the design needs to start with the user. So what is it they need? What information, data, voice, video, whatever it might be? What's their concept of operations? Are they using small terminals, large terminals? How much data down to those? And that will have then a bearing on those link budgets and whether they can use a KA band, a QV, or if they need hardened X band. And it's really horses for courses. That then leads on to, and then of course the threat also needs to be thought about in that early design work. That then leads on to space segment. What are those transponders going to be, the antennas and so on? Do we need beamforming? That sort of thing. And then that in turn will lead to the ground segment design. So there's a real holistic systems of systems approach to the design of the ground segment. It can't just be done in isolation from what the user needs and what the space segment is going to deliver. So what does the future hold? So Airbus, central to our vision of our future space and defence architectures, the need to address really three key questions. The future operating environment. So what are the needs of the user likely to be in, let's say, 2035, 2040? So we know where we are today. We heard a lot of things yesterday about technology developments and so on, but where are they going to be? What are they going to need in that time? Because we have to think about that now to be able to exploit the technologies that are going to be arriving in those time frames. So those technology roadmaps leading towards that time frame. What's the architectural evolution? How's the development of the future MilSatCom architecture likely to evolve? All those things I've just said, really. And how do we integrate the environment that's needed? And that environment, as I'll show you in a minute, I think, is very complex. So working to understand the future vision is something we've been thinking about for a long time. So who across those operational domains need access, what information, and how can it best be sent? So bringing this all together in a coordinated way is a significant challenge under those contested conditions that I just talked about. Okay. So you can see here, future operating environments, answering the needs of the end user. So we're probably looking at, in the future, lower size, weight, and power. That's that SWAP acronym that we all know. Probably more combat aircraft with SHF on there, not just using UHF. So that's a big challenge. So higher data rates, higher capacity going into much smaller terminals, which are moving very quickly through the beams of the satellite. The resilience, the future space and cyber threat landscape, as we said, we need resilience against the threats. So that might mean that the resilient modems and those cyber security, so the resilient modems might also need to be in those fast-moving small platforms. So that's another challenge. So to get that level of computing power, much smaller in the future, to be able to do the job that it does today in perhaps bigger terminals. So that's another challenge. And as I said, the development of those things and how they integrate together is all important. Let's just move forward. Just looking at the time. So we talked about combat air. There's also the land element. Future conflicts, they're likely to be needing high capacity services on the land vehicles, and they need to be delivered to the operators in contested urban environments. So where perhaps there's significant environmental shielding or there's jamming effects going on. The airborne we've talked about. Then the battlefield is becoming even more transparent. So moving across there to the ISR element. So ISR means that adversaries know where your assets are going to be, or we know where theirs are. So that's a challenge. So the need for access to information continues to accelerate, and so too will those adversarial capabilities which seek to deny our operational advantage. So the space and cyber domains need these end-to-end architectures to combat all of that. So the architecture. On the left, we've got a physical architecture. That's the space segment, but all important for us in this room, the ground segment. Those entities that provide secure connectivity from one point to another, and the satellites operating across multiple frequency bands, multiple constellations, and being owned and operated by a broad range of vendors. It's that own, collaborate, and access model that Peter talked about yesterday, the allied, sovereign, commercial. So they all have a part to play. So just to summarize, let's go back to the need to position the user at the heart of the concept. So much the same way that we seamlessly roam with our phones, the end user, the warfighter, doesn't care whether it's going over commercial or whether it's going over a hardened geo satellite or whether it's over an allied satellite. He needs his remote terminal just to work, like I said yesterday. He needs absolute freedom of action to connect to the space network via a broad range of those capabilities. So in summary, these key drivers will shape the defence ground segment requirements for the future. So I think that slide really sums it up. I think these will be available afterwards. But on the right-hand side, there are some key considerations. So sovereignty, as we talked about, freedom of action, cyber risk balance. That's okay. So there'll be some points in time where using a high-capacity link over Starlink might be fine. But there'll be other points in time where absolute resilience is required. It needs to go over the hardened GA satellite and link down. Also, again, mentioned yesterday, standards. And I think I need to talk to some of the people in the broadband area to learn about that and really get involved. Interoperability, we talk about allied by design. So thinking about how we're going to work with allies right from the start of designing the capability from that end-to-end piece. Defence and industry alignment, I think we might talk about that in a moment in the discussion, but that's all important. Unless we have a strategy towards getting that capability needed that defence and commercial and industry are aligned on, then we're not going to get there. So finally, leading to that discussion, let's consider the wider factors that will shape the ability of the UK to deliver this future space network architecture. A bit like the Olympic rings. So access to technology. So as we heard yesterday, there's some fantastic companies with great technology, always moving forward with that R&D, and the defence ground segment, defence mil-space networks need to tap into that. I think a quick win will be using some of that commercial off-the-shelf technology, but then putting that cyber wrap around it, or that resilience wrap around it. Similarly, a more integrated approach to modelling and simulation in our system engineering practices will ensure effective integration from the outset. But the further development of those niche capabilities will need significant funding. So that's not the COTS, that's the niche elements, the resilient protected modem, all those cryptos that are high grade, and not just the AAS 256, that need to be developed and need to work in that environment and be able to pass high capacity of traffic, which can quite often be the bottleneck. So really important that we move forward with the money and the funding to actually develop those niche capabilities. And because they're only needed for defence, the market isn't as big as, let's say, the broadband market. So where's the money coming from? At the moment, it's coming out of companies like Airbus, Thales, and so on, CGI, to do that R&D. But I think we can do with some help. So sovereign industrial capability, supply chain resilience. So when I talked to customers with the mod last week, they talked about deliverability and reliability of the supply chain, and also the security in the supply chain. So we have to reach right back through, right down to where the components are coming from, to make sure there are no back doors and so on in the whole build-up of the system. And it's quite labour intensive, I can tell you. This minimises the risks to integration, reduce costs. The full supply chain needs to be involved throughout the whole life of the programme. And I think the global space industry recognises difficulties in recruiting and retaining young engineers and scientists and the talent that needs to be in that supply chain to actually make things happen for the longer term. So, in summary, successfully achieving this vision cannot be achieved in isolation. It needs to be done with all the companies like those that are in this room today, and it needs to be in collaboration, support across government, across industry, to ensure we have that the full potential of the UK space industry is leveraged. And I think we can talk about the opportunities going forward from that, should we achieve it. Thank you.
Good.
Sure. And the microphone stood up. That was quite good, wasn't it? Problems. Always worth testing before you start.
And I hope I am.
You're on.
Yeah. Thank you very much, Steve, for coming along today. And
Welcome.
God,
Good to be here.
yeah, we've been all over the world, haven't we? Australia and
Yeah, indeed. Sydney was the last one, I think.
yeah, on the stage and
Indeed.
it's just good to be back in the air. And one of the questions I haven't got down here, but I was going to ask you because it almost came up yesterday. What's it like when a new government comes into power?
That's a big question. You want me to answer it in the context of this or everything?
In the context of
of course. So what we've seen, and I don't be speaking out of turn, and Pete alluded to yesterday, I think. So I think I'm covered. Of course, the new government coming in. There's a strategic defence review going on right now, and that always happens when the new government comes.
Yeah.
They want to check through, and particularly when they come out straight away and say we've got a budgetary, problem, which they have done, and so they'll be looking at all of those programs that are not committed, those that are still in in the procurement phase, and saying which ones of these do we really need, which ones of these can we shelf for a little while, which ones don't we need at all, it's a vanity project. I hope there aren't any of those.
Yeah.
But I think you understand there's those levels of importance. So what that means is, you're working for a period of time on those opportunities, spending quite a lot of money probably, and
this is private industry.
Private industry, actually, I was referring to ourselves, Airbus, and others in the room, and then things get put on pause. So something you worked on for a year or something, it's put on pause. Okay, so we wait, and then there's uncertainty. And you might say, well, that's life. But there are challenges that creates in terms of keeping people in their work and so on, because you're relying on those contracts to be fulfilled and come forward to keep going and keep moving with the technology and with the skill sets and so on. So it does have a bit of an impact. Hopefully, the SDR will go through. There's already been commitment to 2.5% of GDP, I think. That's been said. So hopefully it's a pause and not a stop. So yeah, it does impact. And those are the ways I think.
Gets a little bit nervous for a while, yeah.
Yeah, indeed, absolutely, yeah.
So for you, what made the Skynet PFI such a success?
Wow. Well, for me personally, I had a job for about 20 years. That was great.
Can we promotions?
And lots of people in this room as well, Maris. But no. I'd like to answer it in if I put myself in the customer's shoes, really, and say what I think was good about it, or even in the user's shoes, which I think I can do, having been there. As Pete yesterday said, defence, it always needs to be on for the user. And I think we were successful in achieving a capability because we had that ability to deliver a system, people, processes, tools, all wrapped into one system of systems to deliver to the end user. So that made it a success. It meant that an investment that we made at the beginning, we then have a long period of time to plan those budgets and to be able to spend some money on R&D and so on. And then when those new requirements came in, we were able to respond to those really quickly. We were deploying new capability out in 6 months. These days it might take, I think it's Pete alluded to, you might be talking some years. So the end user would then be frustrated that why can't I have this capability? I used to get it. So that was good. In larger terms, I think the risk transfer. I know Pete talked about losing that suitably qualified and experienced personnel from the military.
You were one of those, yeah?
I was. Yeah, exactly. So I left the Air Force on Friday afternoon and joined Paradigm on the Monday morning and changed my suit, but not too much. I was still wearing blue. So, yeah, they lost that for a period of time. But the thing was, they transferred the risk to industry. They didn't have to worry about how something was delivered. They didn't have to think about, we need to sort a budget out for 3 years' time because we've got to compete this thing again, or we've got to buy another, capability to slot it in somewhere, and how do we integrate it? All of that was taken care of, and company, industry took that risk. It was a consortium. It wasn't just Airbus. CGI were with us as well in the room, and some others. So I think we delivered a really good service, and I think those are, so for the user and for government, for the economy, money at that point in time, early sort of late 90s, 2000, to spend out $2.5 billion in one hit was a big ask. Money was quite, you remember the interest rates back then, it was a lot different. So we were able to, really help government in that way, with that longer term mortgage, as it were. And it might have appeared expensive to the users. They're paying more for because it was a pay-as-you-go, essentially. The services were paid for over time. And the users might have said, well, okay, I can get commercial bandwidth for much less. And that's true. But at the end of the day, it's paying back, the $2.5 billion that was spent on 4 satellites, not just, that bit of bandwidth that you're buying amongst thousands of other users. Yeah. So it's a different kettle of fish. But those are some of the aspects of it.
Okay, so the MOD stated that they are challenged by the lack of SCEP and call the current arrangement tactical. What do you think can be done by the government to enable, the future success of Skynet?
Right. So that's the key question, I think, that Pete Lim and others have got at the moment. Interesting that he called it tactical. I guess in terms of time frame, for a 5-year contract, you can't really invest that much in that period of time. So what I think they need to look for is collaboration with industry and a longer term arrangement. I know it won't be a PFI. That's not a thing that's going to float at all. But some way of not having the number of contracts that they have to let. That's obviously very difficult for them. It costs a lot of money, takes a lot of time and effort from government. But also, to smooth out that demand, to have some surety about industry needs to provide that SCEP for a long period, and they can plan that. So I think a longer term collaborative, let's say an alliance or something of that nature, needs to be put in place. I think there is a similar thing for the shipbuilding, so why not space? Let's help space to succeed in the same we do with our shipbuilding industry, and not waste the fantastic industry that we've got in the UK and let it wither on the vine. So I think it's really important, something that's...
Of course, our lead-in times are always longer than what the government understands.
Exactly. Things get delayed, frustrated users, so yeah, let's get that longer term thinking, that's more strategic thinking in place rather than the tactical. Yeah.
So what are the key technical challenges to reach the needs of the future warfighter?
So I won't go into the dBs and the watts and so on, but technically we saw how complex it is, and telecom is complex enough, but when you add in those niche requirements to meet those threats, and it has to be, sovereign on a site, so you can't just outsource something and put it in the cloud. You need to have those all those capabilities brought to bear.
Are we still are we like dinosaurs about the cloud? Or are we?
I think that's a question for for the MOD and defence, they have their own cloud. So they do have some restricted cloud capability. If they want to use that, that's great. I think their concern is that they want to have absolute surety of security and that control. To put on a company and say, you're a cloud operator, you've got thousands and thousands, millions of customers, but my part, I want it to look like this, is not going to really fly. It's not that it can't be used for some of the applications. As I said, it's a bit of a golf bag approach, but there's going to always be that kind of, the hardened geo and its associated ground segment, I think, that's going to be, needed to be safe and secure and under control. Yeah. So, but in general, I think having that distributed architecture with that own access, collaborate model that the MOD want to have, the key technology, yes, not just technological, it's contracts, it's ways of working, it's collaboration, but it's going to be the sort of network management systems and the systems that make all that architecture work together seamlessly. So people in the audience probably thinking now, well, that's about standards and interoperability, and it is a lot of that as well.
Yeah, that's good. So what about SCREP more broadly in military space? Why is it such a challenge?
I was listening to a program on Radio 4 the other day, obviously reaching that age, and it was talking about rearming the UK. That's a bit scary, isn't it? Why are we doing that? Are we going to war? But essentially, the challenging times, geopolitical tensions, and so on. We are obviously, the UK is obviously supporting, Ukraine and so on, and it was about Thales were featured on this program, and they're I think doing very, very well. Rates of business, okay, but that they had a huge demand put on them, by the Ukraine conflict, to say we need to provide missile defense systems yesterday to the Ukraine. Well, they couldn't just stand up, that capability just like that. And that was the challenge that they had, and I think it's the same in space, because the skills to build a missile system, and I used to work on missile systems. I think we were talking yesterday. Pretty niche. MilSatCom, as we've talked about, there are those niche products, niche equipments that need to be there, and the ways of wrapping those in that high level of cyber security. So we need some pretty niche skills, and that's the challenge, really. Yeah, it's a very similar thing.
And it's almost the world over, isn't it?
But yeah, we experienced it in Australia. How were they going to build their 600 people with space capability because they wanted their own sovereign capability? Well, that's a huge challenge.
With sovereign people.
I mean, we did it in the UAE. The way they did it was they took a risk-balanced approach. Clearly, they didn't have Emirati indigenous people with mil-space skills, so they allowed non-UAE nationals, and that's how they've done a lot of their business, by bringing in the expats to then do knowledge transfer and build those skills over a period of time. So it can be done, but they've got to take a risk-balanced approach to it. Yeah.
So what are the opportunities which might help the UK industry to keep the skills and capabilities it needs?
Okay.
For the demand?
So I'm hoping that skies will be one of those opportunities. As Pete said, that they're still feeling their way as to what that will look like, and I'm sure that's it's a very difficult circle. So
that's investment in R&D and
a longer term alliance, that allow surety of what the delivery needs to be over time, not short and repeated competition.
And training and education in universities, and is that all part of that?
All of that, I would say it's it's not just about the technology. I said before, skills, people, and so on, all important. So bringing in the universities, SMEs, and having an ecosystem is what that's all about. Yeah. Other opportunities, as I've said, there's around the world more and more countries are looking to have their own sovereign MilSatCom, and I think the UK's got still, as Pete said, Skynet's, he's looking for a future for that, but we have got great capability now, which we can export, and so if there's demand there from other nations that are willing to buy in from the UK, then that helps us to keep our square as well. Yeah, it's good for the economy because it's exporting our capabilities. So I think that's another area that we will look to exploit. It's good to help help us keeping going to where we want to go. Yeah, indeed.
Do we have any questions for Steve?
What was your opinion about this standardization with previous?
Standardization, yes, yeah.
Space we did that was a military projects. There's always a gray area, double-edged sword, that you go to a black box, which is not known to everyone. We're military and secure the force. Yeah. Follow standard that everyone had access to that standard. It happened the extra security, secure the standard. So it's been always a challenge, at least for me, in this industry for the last 3 years. And purpose? What do you prevent for the future? So you have,
yeah. Can be.
Yeah. You also achieve a little bit standard. What do you? Because I felt that hesitation when you were talking about
that. Okay. I think I mentioned the use of COTS as building blocks within the system of systems, and then putting that cyber and so on around, and having those niche products, next to that COTS as well. It is about building open architectures, open standards. We can have a closed system, but still use those same standards, if you see what I mean. You don't have to connect it to the internet to use the same sort of standards that the commercial world uses. So, put it this way. So, some of the solutions that we have at the moment, customer doesn't want to use perhaps a data center or a cloud, but they still want the virtualized environments. But those virtualized environments need to be secure. What we're doing is we're using essentially the same technologies, products, and so on that you'd find in the data center, but then we put intrusion detection around and ensure they're secure. So I think the answer is use the same standards, but put that protection around. Yeah, if that makes sense. Which I think means that companies like us, we need to talk. Yeah, I think we're part of DIFI, but the broadband one that was talked about yesterday, broadband forum, things like that.
GSM.
We need to be more involved with 3GPP and so on.
That's wonderful. Okay, thank you very much, Steve, for coming along today. And
Kevin, absolute pleasure.
Wonderful to hear the latest from Airbus. Thank you.
Thank you.
Big round of applause.